Next, we have another one of our incoming class of 2020 fellows, and a remarkable class it is. It is my pleasure to introduce Ganapati Yadav, of the Emeritus Professors of Eminence of the Institute of Chemical Technology from Mumbai, India. Please help me in welcoming him to the stage.
Good afternoon. June 21st was a few days ago. It was an International Yoga Day. So I don't want you to go into trance this afternoon because you had a very heavy, sumptuous meal. Ladies and gentlemen, today we are talking a lot about green hydrogen, carbon dioxide. Carbon dioxide is a new oil, biomass valorization, and waste plastic recycling, and all this is related to the so-called net zero goal. So you see that the United Nations Environmental Program talks about energy, buildings and cities, and in country like India, we are talking about smart cities, industry, agriculture and food, forest and land use, and transport. And transport is talked a lot because of its impact on the environment. So, in January 2020, just before the pandemic began, the atmospheric concentration of carbon dioxide was 410 ppm. During the year, there was practically no economic activity. We were closed. I did not leave my home for 2 years. Still, we added 2 ppm to the atmosphere. And you can see that in a year, June 15, 2022, I could have updated the statistics, almost 2.77 ppm has been added. And what is worrisome is that if we continue to add carbon dioxide to the atmosphere, within next few years, the species of human beings will be extinct. And this happened a few weeks ago. And it said that the world is likely to breach the 1.5 degrees C climate by 2027. And we were talking about the year 2100. That means we are emitting a lot of carbon dioxide in the atmosphere. And so the simple solution is that we should not be emitting any carbon dioxide. Look at the net zero target. 27% of the countries do not have any net zero goal. It is the remaining part of the world where we are talking about, whether it is United States, China, the European Union, and countries like India. So the reason why it is happening, because the entire economy is based on carbon. Carbon is required for life and sustainability, but it should not be a part of the energy change. And this is what I'm going to talk to you about this. This we published 3 years ago in a very important journal. So whether it is a renewable resource or a fossil fuel, it is the carbon dioxide which is responsible for all these things. And this is responsible for global warming. So use of carbon-based fuels is the real culprit for greenhouse gas emissions. So you can see this interesting slide here. You see by 2050, 73% of the global energy will come from renewables. And in that renewables, solar, wind, hydro, nuclear, gas, coal will be still used, okay? And so this will be something like 49,000 terawatt hours of energy. 24% of this will be coming from hydrogen, whether it is green hydrogen or blue hydrogen. So let us look at some of these statistics. You see that So there will not be any gray hydrogen, and you know that gray hydrogen is used by refineries to a large extent. And so, this statistics, European Union, the Hydrogen Council, and Bloomberg New Energy Funding, it says that there will be an energy mix from 2018 to something like 2050. It will grow in the range of, say, about 8% CAGR. And there will be an investment of $150 billion by 2030. As far as India is concerned, because I'm involved in some of these policy-making bodies, I can tell you that we would like to have 50% of our energy come from renewables. So you see that if you want to control the temperature of the globe, the atmospheric emissions of the carbon dioxide should be less than 10 gigatons. Then only we can have 1.5 degrees C as the ultimate. Otherwise, it will not happen. So in 2021, we emitted 40 gigatons of carbon dioxide. This is the real statistic. So for achieving the net zero goal, greenhouse gas emissions should be brought down to 10 gigatons only. And so carbon should not be a part of any fuel. Okay, that is one. So you look at one of the things which is talked about is hydrogen, the hydrogen production technology. And this morning, Dr. Sangeeta talked about, the 111. So I'm going to talk a little bit about that. There are many ways by which you can produce hydrogen. You can produce it from coal, you can produce from any hydrocarbon, or you can produce it from water, for example. So one of the things people talk a lot about is electrolyzers and electrolysis of water. But is that the only technology? And the entire world is sold to electrolyzers. But believe me, electrolyzers will not give you that 111 target. Believe me. So we have done some calculations, and you find that it is not possible unless we think out of box. So one of the things which we were working on is the thermochemical water splitting. There are many cycles. There are more than 216 cycles in thermochemical processes. We concentrated on the copper-chlorine cycle. And so I'm going to talk a bit about that. So this is the so-called 111 target. Now, there is a very interesting anecdote for 111. Those who know the game of cricket, 111 is a bad thing. If you are playing on the score of 111, that means you are likely to get out. So here 111 is the target for this, which is DOE has said that 1 kg hydrogen in $1 in 1 decade. Can we achieve it? And this is the goal for everybody, every technologist. So you see that what is believed is that the liquid hydrocarbons, liquid sources of energy will go down, oil and natural gas, and by 2100, it will be only gases which will be used. This is a prediction, okay? This is based on certain statistics published in journal Fuel. So look at the main hydrogen production electrolyzers. One is the alkaline electrolyzers, the anion exchange membrane electrolyzers, and the proton exchange membrane electrolyzers. This is known to all of you. Okay. So you see the problem with electrolyzers, the technology development, there are many problems like polarization curve parameters, like the current density, the overpotential, the polarization curve slope, and catalysts, very important, catalysts, the membranes, and these are all very expensive. So this is one of the reasons why the electrolyzer technology is very, very expensive. And perhaps because you are Americans, most of you, you know that your government is giving a subsidy, incentive of $3 per kilo of hydrogen. So even if your cost is $7 or $8, you get a benefit of $3 from the government, which is not the case elsewhere. So this is very important. So if we look at the hydrogen demand by 2050, whether it is blue hydrogen or green hydrogen, this is what is going to happen. There are different statistics, like International Energy Agency, the Hydrogen Council, and Energy Transitions Commission. They predict different, percentages of hydrogen. But that is true that whatever we may do, hydrogen demand is going to grow in future. So, and at the same time, look at the carbon dioxide emissions. Coal gasification. So if you have coal gasification, you take coal to syngas, and then syngas, you Fischer-Tropsch synthesis, you can produce a variety of chemicals. So this is well-known technologies. Germans were the first who did it, and the rest of the world followed. Then steam methane reforming, which is a major hydrogen source for refineries. All refineries use steam methane reforming. Then you have wind, then you have solar, and all sorts of things are there. But the carbon dioxide emissions, which are expected to be, coal gasification will be 19.14 kilogram of carbon dioxide per kilogram of hydrogen. And I will give you a little more statistics a little later when I compare with my own technology. Okay, so look at this. So what is important is, because we will be exhausting most of our resources, so circular economy and the so-called recycle engineering. As a professor of chemical engineering, I found there was a less interest among students in going for chemical engineering courses. So I said, I have to encourage the students to go for chemical engineering. One of the things what is going to happen is hydrogen will play a very dominant role in all technologies in future, and I will show you by example. And chemical engineering will be prominent again. Why? Because chemical engineering has a lot of things, and this is related to recycle engineering and the so-called, circular economy. Chemical engineering deals with physical rates, chemical rates, biological rates. So material recycling and sustainability and so-called creation of a zero-waste society, which seems to be an impossible goal, is what we should be doing. So, and you see, around the year 2000, we introduced solar energy, wind energy, and all these, now they outlived their life. So there will be a lot of waste of this. Solar panels, the wind panels, everything will be now available. You cannot just dump them in atmosphere. You have to recycle them. So this is where the so-called circular economy plays a very important role. So you have to diverse the linear economy. Otherwise, we will require 3 Earths. That is what sometimes people say it will be 5 Earths. So we see that. So what happened, last year, Government of India announced a very big policy. And this is called the so-called hydrogen policy. And in that policy, the government wants to meet 50% of the country's energy requirement by using renewable energy sources. Today, India has 84 gigawatt of solar energy. And our ambitious goal is to go for 900 gigawatt and be an energy export country in a near future. So this is a very ambitious goal. And perhaps India is the chairperson of the Global Solar Alliance. And India's target for green hydrogen by 2030 is something like 5 million metric tons. So what it means, it is water and air which will be feedstock. You take hydrogen from water, oxygen from water, and nitrogen from air. So this is very interesting. So you look at the specific energy of hydrogen. Hydrogen per kilo has the highest specific energy in comparison with any of the fuels. Okay, and you can use it for anything, like 2-wheelers, 3-wheelers, 4-wheelers, IC engines, okay? Then synthetic fuels from carbon dioxide, upgrading of bio-oil, hydrogenation of biomass, and many things. Chemical and allied industry uses very small % of hydrogen in comparison with, and including the waste plastic recycling, and I'm going to tell you how hydrogen will help to recover valuable chemicals and materials from waste plastic. So look at the ammonia, green ammonia. So you take, water, you have solar, wind, or hydro. These are the renewable sources. So this becomes, then you have water electrolysis or thermochemical process. You get green hydrogen. And from air, with pressure swing adsorption, you take nitrogen out, and you make green ammonia. And this green ammonia can be split to make hydrogen and nitrogen. So beauty of ammonia is that 10 atmospheres, you can store it, and already ammonia infrastructure exists, like countries like Germany are far ahead of that. In case of hydrogen, you require 300 to 700 atmospheric pressure and cryogenic conditions. So you require that kind of infrastructure. So that infrastructure is not there. The beauty of ammonia is that ammonia can be used for the same purpose for which you want to use hydrogen. So directly ammonia can be used in turbines, it can be used in boilers, it can be used in fuel cells, name it. So or you crack it. So this is one of the things which is going to happen. So, so you look at the hydrogen demand in refinery, something like 31.5 million tons of hydrogen is required. So the first sector where you can green it, use green hydrogen in refineries. Because refineries use a lot of hydrogen, and that is steam reforming of methane. And that 1 ton of hydrogen produces 11 tons of carbon dioxide. So that is where refineries are highly polluting. So in our case, we developed this ICT OEC technology. This is OEC's ONGC Energy Center. I've been working with them for a number of years now. And so we found that we could produce hydrogen at about 95 cents a kg for 100 tons day per capacity. It's a huge challenge. When the entire world is facing this problem, how can I say that it is less than $1? So we did many calculations. In fact, we are setting up a big plant in Goa, pilot plant. We have done this in all these experiments in my institute, and this will be a big breakthrough for us. So look at this. So in this, I have shown that we use solar energy. We have developed a new molten salt combination where we store this energy, and then we split water, and this is where copper-chlorine cycle comes into picture. It's a 6-stage process. Then you produce hydrogen and oxygen, and this hydrogen can be used for many things, like carbon dioxide to a variety of chemicals. So we studied carbon dioxide to methane and higher hydrocarbons, carbon dioxide to methanol, carbon dioxide to dimethyl ether, you name it. And oxygen can also be used. So you see there are a lot of these chemicals on the right-hand side, hydrocarbons, methanol, dimethyl ether, formic acid, formates, syngas, name it. So hydrogen from water splitting is going to be the savior of the world. In fact, I say this jokingly, you have a trinity. Like in Hinduism, we talk about Brahma, Vishnu, Mahesh. In Christianity, you talk Father, Son, and Holy Spirit, the trinity. So I say hydrogen, like solar energy, wind energy, and hydrogen. This is the trinity, new scientific trinity. So the cost of electrolyzers, which people have predicted, $1,100 per kilowatt in 2020, and it has to be brought down to $220 by 2040. Okay, and if you have carbon capture and storage, the cost of steam reforming of natural gas, that goes up. So you can see that green hydrogen, what is predicted, should be in the range of $1.3 to $2.9 per kg. So this is what has been predicted. So let us look at some of these issues. So we did this analysis, and I can tell you that if we have a capacity of $1 per day, we produce hydrogen at $10.51 per kg. If you go to 50 tons per day, it becomes 1.12. And if you go to 125, it is less than $1. This is what our calculation showed, and this is what encouraged us to go for a big pilot plant. So you can see that. So I have compared these different grades of hydrogen production processes. You see, brown, gray, turquoise, blue, green, and green. So green, the last column, is my technology, okay? And this is based on thermochemical processes. You see, when you have coal as a feedstock, you produce 19 tons of carbon dioxide per ton of hydrogen. And go on the right-hand side, you see that you have green hydrogen, it should be 0. Even the natural gas gray hydrogen, the steam reforming, which refineries are right now doing, it produces 11 tons of carbon dioxide per ton of, and the cost range is given. So these are ideal costs, really speaking. So when people are using electrolyzers, the cost of hydrogen is anywhere between $7 to $8 per kg. Okay. So you see that hydrogen usage in refinery, there are 8 processes where hydrogen is required, and right now they use it. So hydrogen is a very, very essential feedstock for refinery. And even if you take biomass, hydrogen plays the same role. So you see that the refinery processes, whether it is cat cracking, hydrotreating, hydrocracking, and catalytic reforming, or many of those HDS, HDN, HDM, all these processes require hydrogen. So is the case with biomass. Biomass requires both hydrogenation and oxidation reactions. So these are very important for us. So one of the things what we can talk about is carbon dioxide. So carbon dioxide is taken as a liability. We can convert carbon dioxide into a variety of chemicals, whether it is urea, methanol, dimethyl ether, name, all these chemicals are possible. This is one process. So one of the things government of India is talking about the so-called methanol economy. And why methanol? Perhaps you know that the race cars use methanol, and it burns without any flame. So methanol is a very important fuel additive. Now we are talking about ethanol and so-called bioethanol, but methanol is going to be very important. So, and methanol can be produced from carbon dioxide. Okay, same is the case with dimethyl ether. So on the contrary, what we have been saying, bioethanol should not be used as a fuel additive, although the entire world is talking about it as a fuel additive. For a temporary period, maybe 4 or 5 years you do it, but later you abandon it. Because we can use bioethanol for a variety of different chemicals, and we can valorize it more than anything else. So yes, so carbon should not be burnt as a fuel. That is the conclusion, okay? And it should be used as a source of chemicals and materials. So this is one of the things which we talked about in our paper. So waste biomass valorization, again, hydrogen rules, okay? So water splitting becomes very important. See, this is a very big problem in a country like India. We burn something like 330 million metric tons of agri-waste. And this creates pollution. And so you cannot land in Delhi during December and January because huge pollution. So there is a very poor quality. So what one can do, we can have this lignocellulosic biomass and create a variety of chemicals. And in all these chemicals, hydrogen plays a very important role. So green hydrogen at that. So this is one of the things which we talked about. So you can have a rich catalog of catalytic processes. You see the C5, C6 sugars, and I used to jokingly tell the Indian farmers, we don't require sugarcane. I can produce it from all this lignocellulosic biomass. You can see that. So and all of these reactions, there are catalytic reactions, and all of them on the top, they require hydrogen, hydrogenolysis, even in the bottom, lignin, do hydrogenation or oxidation and produce variety of these chemicals. So hydrogen, once again, plays a very important role. And so you can see lignin, so you can make many, many products from lignin. And the other issue is plastic ban. Across the world, single-use plastic is banned. According to me, it's a bad idea. Why am I saying so? Because if you ban anything, people find some clandestine ways of reusing it. And so authorities don't know that. So it is what you have to encourage recycle of plastic. So you should have some deposit scheme. In a country like India, there is a deposit, people will be encouraged to return the plastic bottle or whatever. So ban is not a good idea. If one technology creates a problem, another technology must solve that, and this is the case in the case of plastic. So yes, single-use plastic ban means what? The society is irresponsible. They are going to dump things wherever they like. So you should encourage recycling. That is, have a deposit. You return the plastic bottle or bag, you get your money back. Otherwise, everybody will be dumping it. So encourage recycle and reprocessing. Maybe 50 cents or 10 cents, whatever. People will be encouraged to return it and take their money back. Right now, we don't have that in a country like India. And so that is why we have this huge pollution. So one of the things what can be done in waste plastic is chemolysis. You do hydrolysis, glycolysis, aminolysis, once again, chemistry, chemical engineering. Or you do hydrogenation. Hydrogenation of plastic is the best idea because you can cover all sorts of plastics in this. You don't need to have segregation. That is the beauty of this. So you can see the hydrogenation of mixed plastic can give me hydrocarbons. In any of these gases, PVC, for example, HCl, you absorb it, or PET, even water, or polyamides will be ammonia, or rubber will be H2S, and these technologies are known in refineries. So we don't have to reinvent. So plastic recycling, upcycling, and downcycling, there are new business opportunities. This will be a new source of feedstock. So waste plastic should not be taken as a liability, but it should be taken as a resource for converting into a variety of things. Same is the case with steel industry. Steel industry emits a lot of carbon dioxide. So green steel is using hydrogen. So you see 1 ton of steel produces 2.38 tons of carbon dioxide. So steel industry, nickel industry, they can be certainly encouraged to use hydrogen, green hydrogen. So some of the efforts in my own lab, we produce green hydrogen. We have converted carbon dioxide into fuels and chemicals, biomass to chemicals, waste plastic chemicals, and biomass to hydrogen. This is what we have done. We have several international patents. My work is supported by ONGC, that is Oil and Natural Gas Commission's Energy Center. And we are building a big pilot plant in Goa now. So this is copper chlorine closed loop cycle of water slipping. And we are using solar energy. Okay? And so we have carbon dioxide into methane and higher carbocarbons. We have got patents. So we can use any carbon dioxide source, including coal-fired power plants. So that is the beauty of this. Once again, it is supported by ONGC. And then another is carbon dioxide to dimethyl ether. These fermenters produce huge quantity of carbon dioxide. So one of the companies, Godavari Biorefinery, they joined hands with me. And they produce something like 300 tons per day of carbon dioxide. I said we can make dimethyl ether. So we have a big pilot plant now on this. And then carbon dioxide to methanol, because methanol is a very good fuel for blending. So this is also we have done. So green methanol, green fertilizer industry, and name it. And then biomass into hydrogen. So we have done steam reforming of methanol, ethanol, L-butanol, glycerol, ethylene glycol, name it. We have published as well. And these are the 14 chemicals according to DOE. We have worked many of these things. We have got patents also. So this is once again, biomass will be used because we will not have any crude oil by 2050. We'll be exhausting it. So where are we going to get our chemicals and materials? So this is the way to do it. And we have also done PET to ethylene glycol and terphthalic acid. We have got patents and we are publishing. And this work I'm doing with Michigan State Professor Ramani Narayan. Okay, so ultimately, hydrogen is safer than conventional fuels like CNG, gasoline, and diesel. While no fuel is 100% safe, hydrogen has been shown to be safer than petrol and diesel and whatnot. Okay, so what is the way forward for the net zero and sustainability? Carbon negative energy sources needed to have less than 10 gigatons of carbon dioxide emissions. Carbon should be used for making chemicals and materials. Green hydrogen will be the savior of the world. CO2 should not be taken as a liability, but as a new oil, and which should be converted. Plastic chemical recycling through proper incentives to encourage people to recycle. Waste biomass valorization is the way to go ahead for chemicals and materials. So sustainability through waste minimization, recycle engineering, and circular economy. Hydrogen economy can be elegantly intertwined to make many chemicals from waste carbon sources, including C1 off gases. And our patented work in green hydrogen, carbon dioxide valorization, waste biomass utilization, plastic recycling is highly promising. So ladies and gentlemen, I must present this work to you, which is because of many of my students. I have a record in India of producing 109 PhDs. So I must dedicate my work to my students. Thank you very much for inviting me and asking me to make this presentation. Am I supposed to have any questions? I don't know. Okay, yes, Professor Lahiri.
This is extraordinary delight to hear your talk, and I admire your great enthusiasm. And yes, hydrogen is the king. It rules, as you very clearly demonstrated, and it should be the future. But also it is true, hydrogen is coming, as you mentioned, by electrolyzing water. And as you know, in India, many other countries, water is very important commodity. And there are the times when there's a drought, water is very precious. There is no water there at the time. And this drought season actually continues for months. So is it not true you're solving one problem and another problem would come?
I tell you, you are using negative goggles. No, water, when it is burned, it produces water. Hydrogen, when it is burned, it produces water. And seawater can be used. Even otherwise, in cities like Chennai, Madras, they use desalination to get the water. So water is not a problem. So it adds to the cost, but that cost is not much. In comparison,
North Rajasthan and many other places.
No, listen. India has a huge country. In fact, if I have a solar energy, I will go to Rajasthan, put it back into the grid. So it is, this solution is, country specific. But, and water should not be taken. Of course, water will cost, but it is not adding to the cost. 9 kg of water gives 1 kg of hydrogen and 8 kg of oxygen. Oxygen cost today is 13 to 15 cents per kg. Okay, and so hydrogen, with that, it is still beats the everything. So we have done this calculation. That is why government of India is very excited. They have given me 2 years' time to develop this technology. Thank you very much. So your question is well taken. Yeah, please, go ahead.
Very inspirational talk. So, the message is very clear. Hydrogen is the king on the power. One of the issues with hydrogen has been, at least in the automotive industry, has been the safety and accessibility, compressibility, right? So, have you have some thought about this?
Yeah, a very good question. When this gasoline and diesel were introduced more than 100 and maybe 40 years ago, we had a problem of infrastructure and all. We overcome all that. You see, as far as hydrogen is concerned, one of the things people talk about the material of construction and the metals can give way. But all simulations have shown that hydrogen is safer in comparison with gasoline or diesel. Simulations. Now, there are hydrogen cars because these are using fuel cells. In India, hydrogen cars are introduced. Okay, and our transport minister is using that as an example to make people believe that it is safer. Okay, it is not that everywhere you can always fear, like nuclear energy, that means catastrophe. No, it is not like that. Every technology, there is a negative side, but there is always a positive side. And human mind is highly ingenious.
Sure. So the point that I'm making is that,
I understand that.
compressibility of hydrogen gas, and Honda, for example, has electrolysis that you can do, right? So your hydrogen gas stations, California has implemented, and many years ago, BMW made them, right? So they have switched to battery power because of accessibility and safety concern, right? So the question is, how do you then...
Yeah, very good question. I can use hydrogen to make electricity, right? You agree with me? If your battery is getting electricity from coal, it is not clean electricity, clean battery. It is coal-driven battery. So need, green energy even to put power, electricity into the battery. So for safety reasons, people will, in fact, right now there is a debate, is EV better than hydrogen-driven cars? Perhaps you know that. There's a big debate going on, technological. Perhaps time will only tell us. Within 5 years, this is going to be proven. But across the world, I'm telling you, the Nordic countries, Germany and others, there is a huge hydrogen network. In fact, we are a part of this Indo-German hydrogen task force. What is believed that Germany wants to have 10 million tons of hydrogen by 2030. And they want India to supply that hydrogen, part of that hydrogen. So this is going to happen. Believe me, in any technology, there will be always hiccups. Nothing is developed overnight. It takes time. But my personal belief, I'm highly dangerously optimistic. I think things will change. It will be hydrogen's day.
So it seems that this is a great place to end our conversation today. Obviously, there's a lot of excitement and interest and discussion to be had in this area of technology. Let's thank you for being our presenter today. Thank you for your presentation, and congratulations on becoming a fellow.
Thank you.